to launch into a whole bunch of other awesome things out there with Arduinos and other IDEs and a whole bunch of different, some robotics stuff. So if you have any questions, please post them, and we'll just get going from there. So, of course, like I said, both Sal and I are very friendly, and most of you know how effective ACE is. The email list is amazing. And for those of you that have ever been part of it, you know, it's just you put questions up there, and normally there's super response all the time. So my email is up there, ceccato@hotmail.com. And if you want to send something to Sal, sal.iacono@dcdsb, say that 15 times fast, .ca. So for those of you that may be looking for more or have some questions or whatnot, please feel free to drop stuff in the Jamboard or just say, hey, listen. Okay, so without further ado, I'm going to be looking at electronic and control systems, so some ideas with that. So how do you use breadboarding? How do we teach electronics when your kids are at home? You know, normally face-to-face, it was simple, right? You take out your breadboards, you build some circuits, wonderful, but you can't do that anymore. Or what if you want to do robotics with kids, right? And so there were lots of challenges that many teachers were coming up with and facing when we went to this type of model. So the nice thing is there's a lot of great things that are out there that you can actually use. So the first one, like I said, is Tinkercad. So if you'd like to, you can actually open up a website and go to this website. It's free, it's online. It does ask for you to do an account, but you can make a teacher account. You can do a blank account. There's a lot of different stuff that you can do there. It also allows you to do 3D design. So it's not just computer engineering stuff and circuitry and whatnot, but you can do design, and there's lots of other features there as well. One thing you can do is you can actually set up a class, and then all your students, you can give them the link, and then as the teacher, you can actually go in and look at their files that they've built for you. So it's not like an LMS, but it does give you the ability of keeping stuff together. So, all right. We got a bunch of questions in the chat. Do I need to go through anything here?
I think we're good.
Okay, perfect. So when you launch tinkercad.com, you fire up the link, often you're going to see something along this line, and I would strongly suggest you do the educator one tonight. Use your school email for that. And then, of course, if you really enjoy it, it might be something to consider about putting a class together. One of the benefits, like I said, as an educator is that you can do the class, and there are some tutorials on there as well that you can access. But there's a lot of automatic sign-in options through Google, MS, Apple, and Facebook as well. So if you wanted to do this with your kids at home and you wanted to build some fun stuff with them, you can do that as well. So very handy, very easy to use. And then, of course, once you log in, you should get some page that looks a little bit like this on the far left. And what we're going to be doing is we're going to be going to the circuits. But as you can see, there's 3D design, circuits, code blocks, and lessons. But right now, tonight, we're just going to focus on the circuits and how to build them and set them up in Arduino. So I'll give you a second to do that. And I'm not going to get super in depth with this because you really could. I just really want to give you 5, 10, 15-minute overview, show you a few things, show you how simple it is to build a circuit. And then, you know what, you can pretty much do some learning on your own. And of course, if you want to dive more or get a little deeper with it, you can always send an email to myself. Or if you're really, really skilled at using Tinkercad, and I know we have some people like Raj is very good at using it, you know, maybe we can set up another session for a little later on in a month or two or a few weeks later down the road. So please feel free to ask questions, and let's go. So at this point, I'm going to stop the presentation and I'm going to shift over to here. So this is your standard Tinkercad screen when you first open it up. Let's see, wrong one here. I lost my screen. Where'd it go? Where's my screen? Sorry, there we go. So I actually have a bunch along the top here. Circuit smashing. So when you want to actually build stuff, I need to get rid of this. How do I get rid of this window on the side? There we go. Okay, I'm going to push that down here. So on your screen, when you first start up, you basically have a blank slate. And along the top, this will always take you back to the original screen itself. If you want to launch something new, you can rotate, throw stuff out, so your delete button, and then you have the undo, redo. This annotation is a cute little feature that lets you put notes on your stuff, and then this will allow you to make your idea private or public, so you can actually hide it or you can show it. Along the line, when we start using Arduinos, because you can use the Arduino with this button here will allow you to toggle code, and your start simulation button is the most important because when you build a circuit, that's where you're actually going to start. So along the top here, here's a simple circuit I made. That's a photoresistor. So I got a breadboard. I've put a photoresistor in which senses light. I've thrown in a couple batteries. I've wired positive and negative. I got my resistor, my photoresistor. I got my LED. And so I'll show you how to build one of these, but I just wanted to demo it. Once you've built your circuit, you hit start simulation, and you're going to see the simulator time starts. And when I click on my photosensitive resistor, I can increase the power, and you're going to notice that the LED is lighting up or coming down. So it just goes to show you it's really, really simple to build this stuff. So one way to do it, and I got another one here, is you can just go to your original Tinkercad screen, create a new circuit. It actually gives you some weird names. So if you want to change the name, you just click in the top corner. And now you can start to build on your actual screen. So there's two types of sets of components. There's basic, and then there's all, and then there's also some starters as well. The starters are little pre-built packages that you can literally grab, drag onto your board, hit the start simulation button, and it starts working for you. So these are some nice ways to tinker with ideas, but you know, if you don't want to, you can just literally go in, you click on stuff, delete it, and you're done. I just like to build from general. So when I click all, I get all my components. The first thing I'm going to do is I'm going to look for a breadboard. So you can see there's lots of things here that you can go and use. So they've got a full-size breadboard, a small breadboard, and a mini. I'll just drag and drop my regular breadboard. It puts it there on the work plane. Now, of course, we're going to need some battery power. So here, I'm going to take a 1.5 volt battery. And at this point, I can choose 2, 3, or 4. So let's do 2. So that'll give me 3 volts. Actually, we'll throw another one on there. So now we're at. What I like to do with the batteries is you can actually rotate them. So I'll click on it, and then you can rotate it around. And then what I'll do is I like to just sort of pull it off to the side. By doing this, I can then actually wire it. So I'll take my negative, and all I do is I click with my mouse. And if you actually click as you go, you can actually bend your wire. And I like to make things look neat. So go down here, click, click, and then click, and we'll turn that to red. And then I can straighten it out. And so now I have power going into my breadboard. So let's throw in a simple resistor, and then we'll do an LED. So I'm just going to go looking for a resistor. And we keep finding one. And then we get up to the top here, and we're like, there's a resistor. So I'll pull my resistor over. I'm going to put it into the positive rail, right? Because electricity is going to come out of here through the resistor, and now it's going to light up or put power on this column. And of course, for the resistor, I can choose what I want. So let's do a 220. Instead of kilo ohms, we'll go with a simple 220 ohm resistor. And now I need a light source. So I'm going to scroll down, grab Mr. LED here, pull them on. We know that the anode is going to have power going into it, and the cathode, of course, well, let's put them up to ground. And of course, I always tell my students to keep the wire black. And so now we have power coming in. We'll hit the resistor, go through the LED, and then into the ground. And when I hit start simulate, there it is. I actually have the LED turn on. And then you can stop simulation. And it's so simple because all you really need to do is just drag stuff onto the board. You don't like this wire, you wait on it, you highlight it, click on it, delete. Right? You need to move the LED. You can rotate it so that you get something along this line. And now the beauty is, you'll notice that this cathode doesn't actually go into one of the holes of the breadboard, but that doesn't matter. You can actually click with a wire, and I found this is really handy. And now all of a sudden it's still connected. So we've completed the circuit, start simulation, and there we go. So it's so handy to build your circuits on the breadboard. And then as you start to play, there's a whole bunch of different ones that you can actually use. So I have another one here. Let me see. Ah, there we go. This is the one I want to look at. So this guy actually uses a dip switch with toggles and a 9-volt battery. Here I have a tri-colored LED. And so the idea here is that as power comes in, which by the way, that should be red. Silly me. There we go. As power comes through the 9-volt battery, it's going to hit the resistor, and then each one of these lines is going to go into one of the dip switches, and then the dip switches will actually color. So just want to do the start simulation. If I throw dip switch 1, it should turn on red, and it does. So then we can just click off. For dip switch 2, it's blue, which is the line that we're working with. And for dip switch 3, it's going to go green. And now for those of you that know anything about the tricolor LED, I can actually change them. So if I do 1 and then 2, I actually get magenta. If I do 1, 2, 3, I'm going to get white. If I do 1 and 3, I'm going to get yellow. And of course, if I do 2 and 3, I get cyan. So it's a nice way for the students to sort of figure out the color spectrum. And with the dip switches, you'll notice that it's centered on the breadboard, much like you'd have to with a circuit. You actually have to have it separated and broken. Because if I keep the dip switch down, if I was to actually put it, and we have to stop the simulation, if I was to move this guy and I bring him, whoopsie, there we go, put my dip switch here. See if it'll let me grab it. It should. No. If I actually try and move the dip switch and set it up, I'll just grab another one, throw it on. Sorry, I got to find all components here because if you have the basic, you're not going to see all of them. So there it is. So if I actually drag one on and I put it in here in the whole column, then when I try and power dip switch 1, it's going to flow through, right? Because it's the same column. And you don't want that, right? You need to make sure that the dip switch is broken across the center of the breadboard, so that when power goes in on dip switch 1 and you turn it on, it actually flows across the breadboard to the other column to actually allow the circuit to go. Whereas if you do it like this, whatever happens on 25, all of 25 is going to have power, and we don't want that. So lots of stuff. And then of course you could even set this lab up for students. What happens if I change the 220 ohm resistor? So let's do that. I'll go change this from, to 220. So let's go 220. We'll switch kilo ohm to ohm. All right, so I've made the switch, and you can see there's my red, red, brown. Start simulation, and all of a sudden, no problem. Then we're just firing through, right? So you can ask students. And of course, if you actually lower the resistance to nothing, we're going to get an error message saying that we've blown up. So 1 ohm here. This should hopefully, yes, right off the bat you can see. And so in the real world, we would have lost this LED. It would have blown up on us, and we would have to throw it out and spend another $7 to replace it. But here on Tinkercad, it says, hey, the LED broke because of is driven by X amount of amperage while the current is at this. And it just lets you know. So, you can teach to students, and it's a cheap way for them to actually destroy stuff without you costing a small fortune. So, once again, very, very handy in terms of building stuff. And there's just so many different circuits that you can build depending on how you want to set it up. So I do have an Arduino one. Let's close this guy too. Where's my Arduino one? There it is. So not only can you build with a breadboard, but if you want, you can actually build with Arduinos. So if you go to components and you go to all, and you scroll down towards the bottom, you're going to see that they have the microbit controller, they have the AT-Tiny controller, and they have the Arduino Uno R3, which is what I have running here. And so for those of you that have used the Arduino, it's pretty straightforward. We have power coming out of pin 7. It's going to go into my rail. It's going to go through my resistor, turn my LED on, then it's going to ground to my negative, and then there's my ground. Of course, unlike a battery, an Arduino is a microcontroller, so we have to give it some code. So when you click on the code button, you actually have a couple options. You can go text, you can go blocks, right? Which I don't like, or you can go block and text, which once again, I'm not a big block fan, but it'll put it there. And you can see here the code for the Arduino is very simple. I'm going to set pin 7 as an output pin for digital out. I'm going to write pin 7 high, so we'll add 5 volts. We'll do a delay. We'll then write low to it. In other words, we'll take the power off. Then we'll delay. We put that in a loop. And when I run the simulation, you can see that the LED is flashing every 1 second. So you can use the Arduino. You can use microbit is in there as well. So many different controllers. And if you want, I've used the circuits. So I've done a whole bunch of work with the TTL logic, the NAND gates and the OR gates as well with my students. For my grade 12 engineering course, we actually did that. We actually built some flip-flops, etc. So very, very handy. The kids can actually look and play, and they can put stuff in and feel with it. And so to me, I find it's just really, really useful, and it runs on a browser. So you can see here, I have a whole bunch of circuits already made up, no minor gate. And if you want to take a look, here's a full binary adder that I built with my students. And so once again, it's just a matter of playing with it. And you know what? It really wasn't too difficult. I did find, though, that normally for those of you that know how ICs work, you got to give them 5 volts directly. and you would use the voltage regulator to do that. I tried to use the voltage regulator. I found it was quirky. So the best thing was to literally set up 4 AA batteries, and I put a 220 ohm resistor, which dropped just enough voltage to make these suckers work perfectly. But that's neither here nor there. If you want to go into that a little bit more, then definitely that's something we can look at in the future. But I'll tell you, for building stuff with students, very, very simple, very fast. And we got any chat stuff that anybody wants?
I've been watching it for you, Rob. Most people are answering each other's questions here, so there's not a whole lot really to look at there. There was mention there, I had asked about if it allows for serial port monitor, like a serial monitor. It allows for that, and people were asking about breaking things, and you showed that. So I think that we're more or less, I don't think we've missed anything. The only thing was, no, I think Christina maybe, addressed the question of if you use a personal email, it does not get shown to students. I believe the student accounts can't see your email. So if you choose to use a personal email instead of a work email, that should be okay, I suppose. Do you know if there's anything different when you're using your classes?
Well, I'm going to click on my classes now so everyone can sort of see what it looks like. Just gives you an idea. So here's a class that I set up. And when I'm in here, am I logged in as me? I think I am. I might not be logged into my teacher account at this point, but we'll see if I am or not. You can go to the classes. Here, let's see. All right, we'll go here. There we go. So here you can see each one of my students and how the last time they were on here in terms of activity. If I click on Marco, one of my students, I can actually see all of the Tinkercad designs that he's made. So if I go to circuits, because that's all we did, I can see each one of his circuits. So if I wanted to compare it with someone, or if they're having problems with it, and you can see that my students actually played with some scrolling stuff as well. And it's really just a great thing for the students to play with. I had some push button stuff happening. One of the labs I did was like, how many LEDs could you do in series before, things wouldn't work? So in terms of the classes, this is really the feature it gives you, is that you can actually see your students. And then if you wanted to just check up on them, you can go in there as well.
Rob, Ryan had a question about shared collaboration. Can you have multiple people work on one circuit?
I've heard that. So if you go over to, I think I might have to actually go to one of the circuits here. I know they did talk about this. I think Raj, they mentioned it, right? In the session that they did. It's over here up in the top corner. So if you go to share, you can share it and invite people. And I believe they'll get a look at your design. I don't know if they'll be able to collaborate, like physically where you can have 2 people work on the same circuit at once. I haven't had that.
Right.
So if a student is having problems, what I'll do is I'll share the screen with them and I'll say, okay, go to like row 5, and location H, and let's put a line from there to, where we need to go.
Rob, you can basically work on the student circuit yourself. You just click on the student project, tinker this, and you can work simultaneously.
Perfect. Yeah. So there we go, Raj. Thank you. Yeah. So do I do it as a teacher?
Yes.
So I have to be in the classroom? You
click on the student name and what the project they're working on. See, for example, click on one of the students that you have and work on, you can fix the circuits.
Oh, you can fix it for them?
Yeah.
Perfect. So then there you go. So that's the answer there. You go to your classes, fire up your class, click on the students. When we grab one of theirs, we'll grab Marco because, my students have all finished now.
Yeah, so click on the tinker this.
Yep, there we go.
Yeah. You can change the circuit now if you can fix it.
And now that Right.
Yeah.
He can actually see it or she can see it and we can work on it together.
Yep.
Perfect. So there we go, ladies and gentlemen. So at this point now I can go in here and I can move his circuits around and we can work on stuff together. So that's one of the benefits there. So at this point, I'm going to stop sharing and I'm going to turn it over to my partner in crime, Sal, who's going to lead us into some amazing stuff. And listen, any Tinkercad questions, please drop them in the Jamboard or email me. And you know what? We'll have some fun. So thank you. And Sal, it's all yours, bud.
Thanks, Rob. Let me see if I can figure this out here. I am going to, actually, let me just move things around a little bit here to get ready, and then I can share. Share. All right. Oh, it didn't go to the slide I want. Okay, so this is my first time using Zoom for presentations. Am I doing this right? Are people seeing what I'm, the
Absolutely.
slideshow right now?
Yes, we are.
Okay, thank you for helping me out there, because like I said, it's, I haven't been using Zoom. So just to, before going on, most of what I'm going to be looking at is Raspberry Pi and robotics related content. But before we do, I wanted to point out this one resource that might be handy to those of you who are using Arduino. I have mentioned it before in the session, in the ACE group, but this particular one is, I'll mention this, and the next one I'm going to be talking about is Professor Sergio Martin of the UNED, which is in Spanish, of course, but it's basically the National University for Distance Education in Spain, in Madrid. So they created this Arduino lab, which allows for students to be able to try programs on preset peripherals. So what did I do? My mouse has gone crazy. Here we go. So this is what it looks like when you first click on it here. And there's two options, Arduino Cube and Arduino Sensors. Now, the Arduino Cube wasn't working when I tested it. I emailed Professor Martin there. He said that he's unfortunately out of town, so he couldn't reset it. He was going to try and get somebody else to do it. So I'll click on it and we'll see what happens. It starts at, oh, and it's not even showing the cube. Someone, I guess, is pointing the camera somewhere else. What I should be, or what you should be seeing right now, is an LED 3D, a 3D LED matrix that you can then execute. You get a 10-minute session. So when you start it, if it's busy, you get queued. If it's not busy, then your session starts immediately. And then you can write your own Arduino code sketch right in here, or you can pick, any of the ones that they have as examples. Again, I can't show you any of them because it's not pointing in the right direction, but basically it's, like this one's fill cube. So it would go through and filling the cube. So again, I think it was a 4x4x4, if I remember correctly, in terms of the LED arrangement. And then you compile it and run it and you can watch it, right? And so, you could have students use this as a way to, write their own sketch and try out whatever it is you might want in that regard. The other one, let's see if that camera's pointing in the right direction, Arduino Sensors. Well, you can see part of it. There's normally a lot more. Normally this is filling the screen. So temperature, barometer, accelerometer, light, there's all sorts of different ones that are available there. And again, with lots of examples here again. So, if you wanted to run the accelerometer code, you can execute it. Again, you basically just hit that and then you hit run and then it's running. Now it's writing its data to the LCD screen, which you can't see because it's off screen right now. It's at the bottom. But this is the first time I've ever seen a camera off screen like this before, but it might be something of interest and something that I think could be, at least in a virtual world where students are maybe not having access to an Arduino, this could be a good something to dovetail in, like let's say if you're using the Tinkercad Arduino stuff, to be able to kind of go, okay, well, try it in real life. Maybe what does it look like to be able to read that information in real life, at least to some extent. The one sort of downside, of course, is that, you're reading, light sensor values, barometer values, temperature values that are present in the lab in Spain, in Madrid at that moment. There isn't any control over those aspect of things, but I still think it's a pretty neat thing to be able to watch live your program running on an Arduino, somewhere on the other side of the world, right? So something of interest there to start off with. And of course, like Rob had mentioned, obviously, if there's any questions or anything, by all means, throw them in the chat. And same thing as before, right? The Jamboard, and of course, in the future, of course, discussion through ACE groups or emailing me if you'd like any resources or anything like that that I maybe present. You're welcome. I invite that very much. So there is the first one. Now, going on from here, we'll be looking at Raspberry Pi. So way back when, I think probably, I sometimes feel like I'm the only one, but way back when it sort of became this, are we going to, our teacher's going to use the Arduino or are they going to use the Raspberry Pi? I feel like I went left when everybody went right. I went Raspberry Pi. I personally liked it simply because of the fact that it was a full computer. So if I wanted to, I could run that completely separate of any of our network or anything like that, hook it up to a monitor and away you go. So I actually have my students do that in class when I'm working on that. They plug it in, I have an extra monitor cable sitting there, so they plug it straight into there, they power it up using the USB cable right to their computer that's in front of them. They take them keyboard and mouse out, plug it right in, and boom, away they go there. They boot up their computer and away they go. Of course, virtually because of situation, finding solutions for online was difficult. Again, Sergio Martin to the rescue last May for me. Coming up with this as a option was a bit of a godsend as far as that goes. So this is an online simulator that he created. Free, no account required, anything like that. It does virtually everything that a Raspberry Pi is capable of. You can do analog natively, I should say. Analog output via PWM. You can do digital input and output, and of course programming using Python. It does provide some examples. So here I say A1 through A8. So here's the link. It says A0. So if you want to see any examples using this link, you can just simply change that to a 1, 2, 3, 4, 5, 6, 7, 8. Well, let's have a look at that. So here is what the environment looks like when you are here. If I run play right now, you see this visualization of the GPIO pins that you'd find on a Raspberry Pi. It also shows them by regular sort of board numbering and the GPIO pin numbering. So you get the BCM numbering and the other. So you can use whichever mode you prefer when you're doing your code. I've always been partial to BCM numbering, so I always have my students use BCM numbering, but you could technically use either one. You can see that obviously some are reserved as usual, and some are the general purpose, right? You're able to assign them as either input or output in your code. These are all basically toggle switches right now. So by default, you can see that all of my GPIO pins are actually set as input by default. So if I haven't programmed anything, by default, it's input only. So I'm going to close that. Let's do a quick, let's start with the PWM. Notice it's using the exact same, if you use a Raspberry Pi, there's the same GPIO module library that you might be using normally on a Raspberry Pi, so it uses the exact same thing. So here's a little code that's using the PWM using a frequency of 1 hertz, running a duty cycle from 0 up to 100 so that it will slowly increase in speed. Notice it's going to be, I'm using BCM numbering, so it's pin 17. So we'll look for that pin, and you'll see it right here. Now you see it looks like an LED now. So it's blinking slowly. I don't know how well this shows up over Zoom, over sharing screen, but it's slowly increasing its rate of blinking, right? To the point where once we get to near 100% duty cycle, the light will be virtually on constantly. You can stop it early if you need to, or just tuck this away if you need to, that kind of a thing. And there it's at 100, and then it stops. And when it stops, it just reverts back to default. Okay. So there's the idea of using a PWM. Let's have a look at, this is an assignment I have my students do. This is one that basically has a light switch that you can basically toggle. So If I run this one, I do have it set so it outputs a little bit of data to the screen here so that students can create a little bit of a UI even in this virtual environment so that they can make sure that everyone's clear on how to use this particular application and what they're doing. So as it says here, BCM3 is used to control the LED at BCM2. So this toggle here is being used to control this LED. And then it says you can hit BCM4 to end program. So right now, if I hit this, we see the LED turn on. If I turn it off, then it turns off. Pretty straightforward, but certainly a good introductory kind of a thing in there in terms of realizing, using input and then executing GPIO output in order to be able to do that. And then this one will, of course, end the program, as I said. So if I click that, you see the way the whole thing ends. Everything reverts back to normal. That's the way I program that while loop. Just a word of caution, if anybody does decide to use this, if you're going to print anything to the screen, don't attempt to do it while you are doing any GPIO work. You'll notice here, I have it up here above because I found that, and I confirmed it with the professor there in Spain, that if you put it in sort of anywhere in the middle of your code, especially inside of your actual code, your loop, it'll actually hang the simulator. So you can't have, which was unfortunate because I tried to get my students to do things that would output messages based upon certain pins that were selected or things like that, and none of that could actually happen. But just a word of caution on that one. So that's the simulator in a nutshell that that can be used. I don't know, is there any questions maybe, Rob, that might want to be addressed before I move on? Or
there's one question about Brendan, which is the Pi's analog input lack of.
Yes, that's the one thing I don't like about it. But the reality is like I said, this simulator does what a Raspberry Pi does natively. So
Yeah.
A Raspberry Pi doesn't have built into it a digital to analog or analog to digital converter. So there's no way to do that otherwise. It is something that Professor Martin has indicated it's something he'd like to add, but at present it's not something that is available. Okay.
That's it. Yeah.
Okay. Moving forward, I started with that. One thing though that I like to do with my classes is I like to do, in class anyway, I always like to do some IoT, Internet of Things. So I like to have them create a program and a peripheral that would then be able to be controlled using a dashboard online. This was, giving credit where credit is due, the inspiration of that really came from Dennis Ceccato of Microchip, who did a lot of sessions at ACE a number of years ago. And he did it all with Arduino. I adapted it for Raspberry Pi. Before I could do that, however, before I could even attempt to do IoT, you can't do it with an online simulator. There's no way for me to do that in an online simulator. So I needed an alternative to this. I couldn't use the online simulator if I wanted to do IoT. So I moved on to using a library that was available on the PyPI website there called GPIO Emulator. It didn't work quite well at first. I did talk to the developer in India, and we worked together to try and get this working. Unfortunately, he's not really too seemingly dedicated. He says his daytime job takes up a lot of effort, which I can appreciate, of course. It only supports digital input and output, which is a little bit of a bummer. I've been thinking about writing my own PWM at least to be able to do that, but I haven't gotten around to that yet. So anyway, let's just have a quick look at the emulator and how that would work. Let me bring up Thani here. So this here is basically the same sort of program that just saw with the simulator, except this will be using the emulator. So if I run this one, the emulator pops up. The colors are a little different, of course, but again, here you can see this is where the LED is connected. This is the control for the LED, and this is the program control that would exit the program when it's over. So again, I can click this to be able to, or hold it in this case, because the other thing you'll notice is where the simulator, it was a toggle switch. This is a momentary button. So in order for me to use the same code, I'm going to have to press that. No, actually, no. Actually, I edited this. Yay, me. you can see here, actually, it's just a matter of getting the right timing. So you can see I'm pressing that to toggle it off, pressing it to toggle it on. And the nice thing is it also shows the value at that particular pin, right? So even as I'm pressing GPIO 3, it shows me that it's a 1 as long as I'm pressing it, so forth. Again, only digital, unfortunately, but it does allow me to take it the step further to do at least some in the online world as it is right now, to at least to be able to do some IoT projects. Just to quickly go back to the presentation here, I mentioned here that because this emulator is locally installed, I can start doing IoT projects. I have been using Adafruit.io, which allows you to create a dashboard, the feeds in order to communicate with the dashboard. So you can create something like this to be able to control that same peripheral through there. So if I click on that, I think it's already logged in. Yes, it is. This is on my account right now. So I created this IoT dashboard. I edited it a little bit from before because I wanted it to be more like that emulator rather than have a toggle switch. I wanted to have a momentary button that I could press and activate. So if I can manage to get this all on the screen at the same time, let me switch to this one here. Oh, let me end that one. Make sure that's properly ended. Okay. If I do this one now, if I run this, there's my emulator coming up. Why am I getting warnings? Unused feed. That seems unlikely. Well, it was working yesterday. So I'm going to hope that these are just some. Okay. I'm just going to hope that I'll hope for the best at this point. There is my, okay, I think I got it successful on the screen there. No, the emulator's not working. Oh, of course. Why would it work when I want to use it right now? Let me stop that. Let's see. I won't belabor it, but if I can find a problem there. How do you control these? Use feed on line 7. Oh, yeah, I don't care about that. Don't care about that. What's the real problem? In the back end, something's going wrong. Well, isn't this something? I don't know if this might have something to do. Oh, you know what? I set this up on another computer. I didn't import all the packages on this computer. Silly me. All right, well, I didn't import all the packages that are for it. Maybe in the end, I can come back to this one after I do the other part of the presentation. I'll import all the packages in the meantime and then be able to do a demo of that. But what should, if I was properly prepared, I guess, what should be happening is the same sort of setup here in terms of this. Pressing this button will turn on this LED, but so will this particular thing. And this will, if I press on this button here, it'll turn on this LED. It'll also represent it here in the dashboard. Likewise, if I press this button to toggle it, it will also do the representation here and turn on or turn off the LED there as well. And then I get my students to, get their phone out. Okay, get on your phone, get that dashboard. You can actually share the dashboard, make it public. They can pull it up on their phone and they can control each other's LEDs, that kind of a thing, or anything else that you can do. Of course, again, because the GPIO emulator only does digital output and digital input, you are limited in some of that. But just a quick, if I go to create new block, things that you can create, you can have sliders, gauges, all sorts of different things that you can, there's an indicator, which I am using, other types of input and so forth. So there's lots of tools that are available there. So again, I'll try to come back to that one. Maybe at the end, if there's sort of questions and chat, I could kind of peel off, get those modules properly imported, and then maybe do another demo of this one afterwards. Just a lot, in case there's questions, I don't want anything to build up. Any questions there?
Nope, I think we're good, Sal.
Okay. Two other alternatives that are worth considering. I think some people have perhaps used this or talked about this before, Trinket.io SenseHat. So if you're not familiar with the SenseHat is something that's used by AstroPi. AstroPi is a Raspberry Pi that there's actually 2 of them on the space station, International Space Station. I had students who tried, who proposed projects to be able to run on their AstroPis in space. It's a pretty neat program, neat process. I haven't, with virtual going on, I haven't really explored that as an option because although I have an AstroPi at school, students have no access to it. Now they could experiment with it here. It is pretty neat. There are some things you can see that's running through some stuff here. You can use sliders to be able to control the temperature sensor and what it's reading, or, you know, the barometer or a humidity sensor, things like that. You can also activate, depending on what you're doing, you can have the control the joystick that's here, and I think some of the buttons as well. I haven't done a whole lot with this one here, but you can see the idea here. There's also, if you scroll down, some other ones. You want to play a game or Flappy Bird on the little, on the matrix that shows up there. So this is the Sense hat that's sitting on top of the Raspberry Pi, which is visible through this box that sits on top of the, or in this AstroPi package. If you are interested in the AstroPi, it's actually a really neat thing. They actually, if it's your first time doing it, they actually send you, the designs to create this and a lot of the tools and everything there. So a lot of it was really pretty neat to just kind of receive that, set it up, and away you go, you're ready to go. So this is a neat place to be able to do some of that stuff, and it does have, you know, buttons and lights and so forth. A little bit more complicated because you're using the Sense hat module instead of just that standard GPIO library, but still interesting nonetheless. And then of course there's this one. Now this is one that I actually might move to. I don't have my engineering course until next quad, so I haven't looked at this in full, but this looks pretty cool to me as well. So this guy created this using the TK library in order to create a simulated GPIO. And so here you can see this kind of like mini lab, almost like that Arduino one in Spain. So you can actually configure this however you want. This is what they call their big lab as an example. And then they have a small one. And so you can just simply add in elements. So you can see here, for example, here the configuration of this one, which is a small one, is putting in some LEDs and some buttons, right? I know I did this one on here. Let's see if this one works for me. I have a feeling it's popping under. Oh, there it is. Okay. So you can see this LED is blinking away as it is right now. This one happens to control LED too. So if I press that, then it controls it, and you can see a little bit of feedback down here in the shell. Press it again and it turns off. And so the idea that you can just simply, you know, tell it, what do you want to see on there, position it. That's a little bit awkward that you have to go through that positioning, but it's not too bad. And then be able to include those. You know, here's the big one, just to see that one in action as well. Again, you can pick what you want, but again, slider here for distance, right, and so forth. So, you know, if I click buttons here and see, you know, you can see this one apparently activates the buzzer, because you can see that little action there on that one. This one says, oh, it's going to report data on there. So distance. So if I change this slider and hit the distance, it tells me again new values. Or the CDS, the light sensor, I could change the light percentages and hit that button again, and it gives me a new readout. It even has this, you can, you know, use it as a remote control if you had an infrared emitter and potentially use that to control a device. But again, pretty neat. I think I might actually be moving to this one. Sorry I left it for last, but I thought this one takes a little bit more work. It isn't found, the module is not found in PyPy. You actually have to download and install it manually. Not that that's hard, but it is something you have to do a little more manual. But then once that's up and running, it's one module and you're kind of ready to go. So there are 2 options. Again, I think this is probably one of the better ones right now. The catch is, of course, that it is an emulator, which means it's installed locally. This is the same problem that exists with the emulator here. So if you end up with having, you know, a few of us were talking earlier before, you know, if you have students who have a Chromebook, that's a no-go, right? It's not going to happen. Now, I tell a lie. That's not entirely true. It can happen if they have full control over their Chromebook and they can enable it, and it's a model that allows Linux mode, and they can enable the Linux mode and then install the full Python package and then install that. Like, it's a lot of ands, but it is possible. But I know my school board, for example, locks down all the Chromebooks that we gave to the students, locks them down into kiosk mode so that they can't install anything. So it's a non-starter as far as if I end up with students in my class that have a Chromebook by chance and they're online, then this or the other emulator becomes a non-starter, and I might have to use something like the SenseHat or find an alternative, whatever the case may be. So there are limitations obviously in that. Moving on quickly to virtual robotics, VEX and others. Really, there aren't a lot of virtual options. There are emulators, which I guess technically are virtual, but the options are somewhat limited. VEX is what I used in the fall with my one class. It does have a little virtual robot that you can see there that you can control using programming. Programming can be done using blocks or Python. There's various different worlds or playgrounds. This one's called Disk Mover. And so you can have it move around, pick up disks, return them into locations, and do sorts of stuff. There's multi-leveled activities and teacher guides already available. There's no virtual learning environment. Everything is through just the simulator online, which requires no login. So if you haven't seen that, just a quick look at that. So here's I think it gives you a little introduction to, this is what it kind of like to see it moving around. We won't watch that though. If you want to activate the world, here you can bring up the world and there's your robot. Of course, if I hit play, there's no code here, right? So nothing's happening. But there's lots of activities. If you want to run and see the code, you can hit code and then it shows you the Python version of that code. If you want to go full on just looking at code instead of looking at blocks by default, you can go new text project and then it comes up in just Python mode. And then you can launch the playground appropriately. The activities are pretty good though, I found them pretty good. There's lots of activities. They're all openly available here and they're all Google Docs that you can then make your own copy of and edit if you want to. And if you go into the teacher resource area, they give you a pacing guide, which I found was not bad. There was some adjustments that I made to it as far as that goes, and some information. There's even some solutions, although I found the solutions to be rather simplistic. I didn't find them all that great necessarily. Most of the resources that are there are designed for the blocks, although they are adding more and more. So if you go to tutorials, for example, project examples for, and it gives you, why did I go there? Oh, maybe it's because I'm in the wrong mode. Oh no, learn. Is it learn? No, that's not the one I want either. Can you tell it's been since the fall since I used this? Tutorials. Or they changed it. Used to be you'd get options first. Just in case it's because I'm in code. Let me see if that makes a difference. There we go. Because I was in text mode, it didn't allow me to, the number of tutorials was very limited. So it's if you're working with beginners or that kind of thing, it might be more beneficial at least to start with blocks. So it gives you ideas on how to use certain things. So I would go through and I'd say, okay, well, look at this tutorial. Initially I started with the blocks and I said, look at this tutorial, this tutorial, this tutorial, and now try this activity. And it worked fairly well. Students were doing okay with that. Students would then just be able to download, save to their device. They'd save their files to their device and then they can submit it to me, that kind of a thing. There is no learning environment, but there is no login, and pretty straightforward as far as that goes. And I even went so far as to create my own evaluations for this. All I said was, okay, we're going to use a particular playground, and I gave them their own task. I said, this is the task you're going to do. Try and complete it. You've got whatever, the period to do it, that kind of thing. All right. So that's VEX VR, and that's really the only one that I've been able to find that is truly online. Free, doesn't matter. You could do it on a Chromebook. You could do it on a Mac. You could do it on anything, right? This is the one I used last spring, Go Coders, except it was free, so I put a sad face there. It changed to cost money now. which kind of sucks because it did have a little bit of an LMS in there, a little bit of a learning environment. The activities were there. I could monitor progress. I could go through all that. I thought it was great. It was Python code using their own library, which was fine. But it was nice to be able to do that because I'm a fan of using Python with this kind of stuff, if you couldn't tell at this point. And so it was great as far as that goes. But again, it costs money now, so I'm not using it. Two other ones which are commonly referenced as simulators or emulators that you could use. Virtual Robotics Toolkit is Lego Mindstorms only, but it only works on Windows as well, and it costs money. And the same thing goes for Robot Virtual Worlds. You can do Vex, you can do Lego, you can do some Arduino stuff on there, but again, as far as I can tell, it was Windows only, and again, costs money. So again, if you have students with a Mac, if you have students with a Chromebook, that becomes a non-issue, a non-starter. You can't, it's not possible. But I thought I would mention them because they were interesting. Lastly, I was doing some research over the past week as I was getting ready to do this little presentation, and I found a couple of other ones that I thought were interesting enough. I haven't had a lot of use or practice with them yet, but I thought definitely interesting enough that I wanted to bring them up here today. So there's the Open Roberta Lab, free, no account, online simulator, various robot platforms. Let's have a look at that one. Ooh, where'd it go? There it is. Just give it a second to load up. Again, it just goes straight into the environment. You can pick what do you want. Well, you know, there's different options. There's sort of some Arduino ones. Edison, MBOT, I know people have used those in the past. I've heard those mentioned before in our forums. You know, there's a microbit. There's actually a microbit simulator here as well. Although microbit does a pretty good job of its own with a make code, so probably don't really necessarily need that. NXT EV3, the Lego Mindstorms. We do from Lego as well. So there's sort of lots of different options here. And just for argument's sake, I'll pick NXT. Okay, you can see it gives a sort of shadow background here. So I can use, again, these blocks to be able to do things with it. I can switch to code and look at, now this is using NXC, right? So again, a little bit more complex. It's not Python. It's not, you know, I know a lot of people would use the Mindstorms maybe with Lejos, a Java version as well. Although I think you can actually pick Lejos if I remember correctly. I thought I saw that somewhere. Oh, I think with the EV3, yes. With the EV3, you could pick a Lejos implementation and be able to do Java with it as well if you wanted. But anyway, you can see the code, and then you can also do a sim. So once you have your robot going, you can kind of go, okay, here's a simulated environment, kind of simulates the idea of picking up, and you can kind of see this sort of dark one that's showing, oh, it's picking up something in that direction. And it allows you to change the scene. So you can pick from different ones, and you can even create your own and upload it. So I thought this is actually pretty neat, especially if maybe it meets into one of the things that you might, if it perhaps meets with a robot configuration that you might be using, might be apt to use. Another one is this robot benchmark. Now it does require a login. You can use any of the OAuth type of things like, you know, Google and Microsoft, that kind of thing. There are lessons, but not an LMS per se. Have a quick look at this one. So here's the idea behind it as far as that goes. And so here's sort of, okay, learn how to use their system in terms of viewpoint control, learn how to do this. And they kind of give them stars to indicate sort of their difficulty levels. Notice I can't start this one because I haven't done these ones yet. So you kind of have to, it kind of forces you to follow, you can't jump straight into something really hard unless you've gone through the learning process of some of the basic stuff. But you kind of get the idea, and you can kind of see some of the robots that are the type of robot that might be in use in that particular type of task, which kind of makes it interesting. Even, you know, a Lincoln autonomous driving and humanoid robots and dog, you know, canine robots, kind of a neat environment as far as that goes. I haven't played a lot with it. I did go in, I looked at the first activity, but I couldn't get straight to any of these right away, and I didn't have time to go in and actually do any of it, so I just skipped ahead. But certainly something that looks interesting to me. And another one, which is more of an emulator that you could install on Windows, Mac, or Linux. Again, if you got Chromebooks going on, that would then become a non-starter unless you get the Linux mode enabled. But this one looked interesting because I noticed it came up in my research in a lot of education papers that were written on robotics in education. So it came up a lot, and so I looked at this one. Cyber Robotics website created this WeBots thing. And so again, it's an open source robot simulator though. Again, available in different platforms as far as that goes. And, it talks about it's used in different things, and there's videos to promote it and so forth. And so it is a download. It's something you run locally. And there are other, let's see if I remember how to, there are a number of sites, can I remember? Here, that sort of shows some of the different applications and where it's been used in terms of being able to simulate a robot before you actually go to production or something like that, right? So there is some really neat, even as a research or as an exploration kind of a thing, might be a neat tool to be able to look at. There was one more that I came across just yesterday. I didn't get to put it in the slide. It was this Juro. Kind of dovetails well if you were in the session last week with Professor Poo of what was it, Ontario Tech, I believe. He was talking about using Jupyter notebooks and things like that. So this does some kind of gyro robot simulators inside Jupyter notebooks, which I thought would be pretty neat. Again, I'm not very familiar with Jupyter notebooks, so I didn't really get too far into looking into it. And it was only yesterday that I found this. But you can kind of see, here's the idea of the robot, and I don't know much about it, but here you can see the simulator kind of going. I guess you can run it right in there and be able to execute it. Again, something that might be of interest, something that we can definitely throw into the chat since I don't have that on the slide to be able to address that. I did search, I just did a search for the robot in Jupyter notebooks, and lots of sort of links came up to it. This looks like it might even be a different framework. So there might be other ones that might be possible as well. Just not something I know a whole lot about at this point, but something I thought I would throw out there as something that might be of value.
Sal, do you want to throw that link in the chat window?
I will in a minute. Yeah, absolutely, I will. I definitely want to make sure that's available. And that was the end of me. That was really the my resources that I had wanted to offer up to the group there. Of course, I guess we can take a minute and go through and look at the any questions that might be out there, or if there's any discussion, that kind of a thing. If there's enough people around, or if that discussion goes on long enough while I try to get that other simulator up and running, I'll see if I can get that running right now. Are there any questions maybe in the group there? Can I bring up the chat here?
I had a question about the API with the SparkFun IoT. There's an API key, I assume. You didn't have to share that with your students, did you? Or?
No, I don't. I have them create their own accounts on there. I do this with my grade 12s. So I kind of say, well, as much as I try to avoid making accounts, that's one that I kind of go, you know what, they're kind of a little bit older. And I kind of get around that. Where's my, yeah, like here I was, where is it, my IoT example. So you can see here's my username and my key. So, hey, guess what? You can now access my stuff there if you wanted to. But anyway, yes, it generates a key, and you can regenerate them. So sometimes when I do a demo, I'll have my Adafruit IO key visible to them. And then as soon as I'm done, I regenerate it. That way, in case someone felt like they wanted to.
Yeah, and the free tier has a few 30 data points per minute or something. So it's good enough to demo, I guess. I think we lost you, Sal.
Yes, I think we did lose him.
Zoom kind of left and then reopened again. I don't know what happened there. But
oh, yeah, you're back.
Did you get enough of that?
Yeah, that's okay.
There is a user account that, but you can regenerate it. I don't know if you heard all that stuff, right?
Yeah. So. Yeah, there's a free tier that seems to be useful, right? So.
Oh, yes. The one thing I will mention as well, you'll notice in the code here that I've got these sleep for 2 seconds to avoid overloading. So in the free tier of Adafruit IO, there's a maximum of 30 per minute. So requests to receive or send data, there's a maximum of 30. So I just tell the kids, I know it makes the UI a little bit awkward because you got to wait kind of for things to happen. But if you don't do that, then it overloads Adafruit IO and it just locks you out temporarily. So to avoid that, you kind of on the free tier, you have to just kind of accept that.
Have you ever tried any? I don't think you can emulate it, but the Node-RED.
I did start looking at that. I can't remember, was it Rado who did a session on that at ACE years ago, I think? I can't remember. Somebody did. And I did start looking into that, and I didn't get very far into that. To me, it seemed like it was a lot more involved, and a lot more, like you had to kind of get everything installed. You had to have the Node-RED set up. You had to configure that, and then you could go into your code and write for that. It seemed like there was a lot more process involved, and I just didn't feel like getting into all of that.
Yeah.
With my students. So I didn't go very far with that one, but I know that is a possibility and certainly capable. I'm not sure what kind of limitations there might be in that one as well.
Are there any other questions in the chat?
I know, just as another aside, I know that Microsoft started a simulator as well. I've tried to implement it a couple of times, but I've never been able to really get that working well. It seems to be trying to lock you into certain things, maybe VS Code or something like that. And so I've never really gotten very far with their particular simulator.
Yeah, one thing, Node-RED was part of the Pi, so I mean, it's already there on the Pi. But
yeah, you're right. The newer versions of the Pi OS does have the Node-RED. You're actually right about that.
One thing that I just discovered watching something about a week ago is the make code thing, for microbit. It now has Python, which is new, newish, which if you were doing some computer engineering and you wanted to, you can't do circuits, but you could at least do similar to what you're doing with the Raspberry Pi and do it in Python or instead of JavaScript or blocks.
Right.
And they have a debug mode where you can slow everything down and watch variables. Again, something I never saw before in the make code. So they seem to be improving it a bit.